some of the slides that were supposed to be gone for some reason did not disappear. So today I'm going to go through some of the resources. Who can perform the test? That's a very gray area and would be dependent upon your code official. What are some of the requirements? How to do compliance, duct tests, envelope tests, and intermixed in that is some air barrier stuff. And we'll talk about how the envelope tightness test, the blower door tests are completely different from what you may be doing as a home performance contractor. All right, so here's a variety of resources, and Jay is frantically copying these in the background and throwing them into the chat window, hopefully. If you go to the official IECC, if you just Google, ICC codes, and you can follow through some prompts. And at the top here, I picked New York and the year, and then it gives me the actual direct access to any of your codes. So if you're looking for a plumbing code or a fire code, and here's your energy code. So these are the things that will pop up. And also your supplements have a direct link that's on there on this page. It's a nice little resource for you. And not in the exact order, but here we go. So if you do have questions about your energy code, here's a hotline. There's also a federal hotline, but this is one that's a little more focused for New York. And the New York State Division of Building Standards and Codes, there's a phone number, and here's also a link to go through those. New York City has slightly different codes, but they're pretty much on the same page statewide as they are with New York City. That's their link. All right, Albany, New York State. At the bottom here is the one that actually shows all of the individual your jurisdictions that are around the state. So again, Jay will be throwing some of those in the background, and you can use your chat window to kind of copy those. Many of you may take a screenshot, but typing in that bottom one may be a little more frustrating for you. And again, you also can download a copy of this. Here's a quick Google link for it, and Jay will send out that link also in the background. So keep checking your chat for more and more information that's out there. This is the most heavy-duty loaded question. I do a variety of training. Actually, this morning I live in Georgia, and we had a code amendment hearing thing today. And I've been to multiple states, and this is always the most difficult question to answer. And it's only a few states really actually itemize who these people are. An approved third party. So what does approved mean? And what is a third party, and does any of that actually matter? So this will actually come down to this person here, who is your code official, and this is how they're listed in the code official, chapter and verse kind of books. The authority having jurisdiction is the God. This person gets to make the decisions. The only person using it to overrule them or change their mind is somebody who maybe directly oversee them. The person who's an authority of this jurisdiction. Maybe you can go to a state decision, but they really stand by the individuals that get to make these decisions. So to me, having a third party is never actually a good thing, meaning that somebody who's not directly associated with the builder or the HVAC contractor. It only makes things cost more money. And the one thing that people hate about the code is I don't want anything to cost me more money. So if people want really the ability for people to do a good job on this testing is that they actually are competent, which is hard to actually test for, but that they're certified and qualified. So that to me is a good definition of who should be doing this. They actually should have some certification proving they know how to use the equipment and do the test. All right. So that's actually the one gray area that you want to connect with your building official and find out exactly what approved third party means. And there's a lot of places when we get into multifamily concepts where your building official needs to brush up a little bit or be more informed. One of the most to me, universal ways out there to become a certified individual allowed to do code compliance testing is BPI's IDL certification. All right, so any of the test centers that are out there can do this. I will be up in New York throughout the beginning of the year and throughout next year, offering this for those who need a certification. Can do that. So any BPI test center can actually do that. So it is an option. It does validate your ability to be technically code compliant as having a certification that shows you can do these tests. Retrotec does offer this residential, this is the duct tester one. There's also one for blower door. So if you buy a blower door or a duct tester or if for some reason you have one from, a year or two past and you're like, wow, I didn't know you had that, and you want to take the certification course, we can arrange that. So it takes about an hour and a half, some basic questions, go through a series of slides, the basic online training program concept. But when you're done, you actually get a certification that says, I know how to use this bit of equipment. I do think in the future, this is going to be something that's combined with, doing hands-on practical training, and something that confirms you know how to use your manufacturer's equipment. And it's our goal in the future to be able to try and help provide something that is actually a physical confirmation that you're actually using the equipment, and we can verify that. So coming to a town near you is a follow-up, or the marriage to manufacturer and third-party certification. Many people are familiar with this concept, but if you're new to the code concept, I want to make sure we understand about how the energy code has been working for quite a while, and there's different ways you can comply with the code. And they're described as a prescriptive path. I call the other ones alternative paths. There's a secondary alternative paths when you just get into prescriptive, whether or not you want to just follow the grid, or maybe I want to add more insulation in the walls. I can do a little less in the ceiling. There's some little bit of play that goes even in the prescriptive path, but in general, prescriptive means I do A, B, C, and I follow these sections, R402.1.3. And if I do this exactly, then I actually am passing the code. The alternative paths are to do what's more talking about the simulated performance, which means I'm actually using usually 9 out of 10 times, it's always a HERS rater or somebody similar to that, and using much more sophisticated software to say this house that I'm building compared to a reference house uses less energy. That's 405. Section 406 is new to the 2015 code, and it's an energy rating index, or ERI. And it basically says that, well, if I follow the ERI, which is really pretty much a HERS rating, and the code says if you get a number, then you actually pass. You're probably around the 55 number. So if I get a HERS rating of 55, and that's confirmed rating by somebody who's competent to use that software and approved, then you pass. So these are your two main options of just following what the code says, or digging in with somebody who's going to help you make sure you pass. If you're doing a home that's a little more complicated, not the standard home that you're doing on a track home, but something that's, a wall of windows or a variety of other compliance challenges that you can't just do with prescriptive, you're going to follow one of the others. Throughout the code is a list of stuff that's called, obviously, mandatory. I know you guys can read the slide. Lighting is one that's mandatory. No matter which path you take above, you must follow the mandatory requirements. Mandatory shows up intermittently throughout even the alternative paths as things you must always do no matter what path you take. If it has mandatory, everybody plays along. This is an example of the prescription that you may follow. This is the prescriptive path, literally the grid. So if you pick your climate zone, most of you guys are 4 and 5. There may be some 6 on the upper section there, but this is the prescriptive path that you would follow. If I just did my ceiling this way, my walls this way, and my floor like that, then your basement, all those things are laid out, and I can follow prescriptively. So there's other things that actually show up in the ICC that people always assumed were in an energy code, but are actually either IRC or mechanical code, or your jurisdiction has already overridden this and done something else. So the M is for mechanical code, the R is for IRC. So you can see that some of the things you may thought of as energy requirements are actually in the residential side of the requirements or in the mechanical side of the requirements. The residential usually includes the mechanical as an incorporation, but in general, these are where these are found in subset sections of the code that's outside of the IECC direct code itself. I'm going to start with duct testing. It's something that some home performance contractors do, so let's use that as a concept. I do have a couple of polls here. Let me just see if we got something we can reach out to. Let's start with this one. This will give me an idea. How long have you been doing this? So are you new to the industry? Been doing this forever? Some people have been doing it longer. I've been alive, and I'm pretty old actually. So just trying to get a feel. So someone asked about res check, and as I'm getting my my votes coming in, I'll explain what res check is. A free software option that's out there for anybody who's doing energy code. And what it does is it allows you to determine what's the overall U value, or in general R value, for your walls, ceilings, and floors. When you want to follow the prescriptive path, if you want to change it, so instead of doing a R49 in the attic, maybe I want to do an R38, but it means I need to put more insulation somewhere else in the building. So ResCheck is still out there, and it still allows you to move things around the building. Maybe you're going to go with a higher grade window, and you may do something less throughout the rest of the structure. And that's a compliance path that still is in the prescriptive mode. So that's one of the options that's out there. And let's wrap this one up. We'll see who's here. So we have kind of a mix. We do have a bunch of folks who've been doing this forever. So some of the stuff will be, I've been doing this forever. This is kind of boring, but I appreciate you hanging in there. I do have some really heavy duty stuff on the specifics about code, especially multifamily. New York has put the entire country into a new path. So I'm excited about that, and we'll definitely have slides on that. Okay, so let's go into a duct testing. And is anybody doing code testing now, following your older code that's out there? So, if there's anything that could give me uh, those folks are like, wow, I'm kind of new to code testing, or I've been doing this as long as I've been doing anything. So, most people who are doing home performance aren't always doing the code compliance path. So, if you've been doing some type of testing out there, let me know. So the duct testing one is one that's kind of the most confusing, and that's why I wanted to make sure that people understood prescriptive versus mandatory. All right. So this is one of the examples just for insulation purposes. So there's a prescriptive saying that you must have these requirements for insulation, and we now have to have for sure insulation around much smaller ducts. So your duct work that's even for your exhaust system must now have insulation, and they describe stuff as being in the attic or not in the attic, and how they describe what R value you have to be and by what size. If you're larger than 3 or smaller than 3, these are the R values. So this was an example of what's prescriptive. So if I follow the ABCs, these are one of the things I have to do for my ducts. Duct testing is mandatory. All right, so you must test the ducts. All right, but whether or not you're passing with a direct number in the code is a prescriptive option, which means that you don't have to get below a certain number if you're using an alternative path. If I'm using the simulated performance or an ERI, I don't have to have a duct leakage below a certain number. That's actually all incorporated in the software and is done through that path. But if I am doing prescriptive, I have to test it and be below certain numbers that I have on my next slide. So a lot of people do follow the prescriptive path, and you must have these uh, these numbers for compliance. But no matter what, you have to test the ducts. So if somebody says, "Oh, I test them," and they're like, "Well, is it less than 4?" and they say no, you can still pass the code with your numbers being above 4. So it's mandatory to test. Passing is depending on the path that you take. So my results, if I am doing a prescriptive path, my rough in with the air handler, without the handler, basically 3 or 4 CFM, or the post-construction test is 4 CFM per 100 square feet. These are common terms that are usually used in the code, or how we describe how leaky something is. You could take out the CFM per 100 square feet and just add a percentage. So that's 4% or 3%. Usually I might say percentage because it's easier to say than CFM per 100 square feet. But this is the only time where you have to pass this, again, if you're following prescriptive path for your code compliance. So you may end up with a higher number, but if you're using an ERI, that gets calculated into how they determine how well that house is performing. Any questions on that? Are we all okay on that? So the blower door is a whole nother concept which we're coming to. There is an exception, and the exception is that I do not have to test anything if all of my ducts and air handlers are located entirely within the building thermal envelope. It's not necessarily the conditioned space, but the thermal envelope. So if you decide that you're going to use a spray foam across your roof line, then that's considered to be your thermal envelope. If all of my ducts are inside that area, then I do not have to test it. I still have to seal them. We all recommend that they still be insulated. The thermal envelope can also be a gray area depending on your code official. So make sure that you understand how he defines the thermal envelope. Usually when the attic is being insulated, usually it's a foam concept, and that is your thermal envelope that they understand that you not have to test, but don't get caught at the last minute knowing you may not have done a great job of sealing it, knowing you didn't have to test it, and to find out you have to do that the day before occupancy. Many of the things that we'll talk about, we'll do the code part, and then I'll talk about some of the things that you can actually do with the Retrotec DM32 Smart Gauge. So in the gauge itself, I can get live results. So as I'm doing my test, I can get CFM per 100 square feet or air changes per hour at 50. These are all things that are very beneficial and make your life a lot easier, especially air changes per hour. And we'll go through some of those and how they work. So when you turn on the gauge, it keeps your previous settings, and it's as simple as I turn it on. I always want to confirm a few things, that I still have pascals. Nobody else messed with my gauge, but all these things are still there. There's nothing for me to test. I don't have to change a mode. I don't have to tell it to do any type of CFM or enter what type of device. If I did a duct test 3 days ago, then it starts up and says this is exactly what you had when you turned off the gauge. So I always just kind of confirm that I've got the few settings I have. And to run a test, it's as simple as I hit set pressure. There is a speed control knob on the fans, but for the Retrotec stuff, we just hit set pressure. I enter 25, and after I usually do that, I always turn on the add feature just as a habit, and I'll explain what the add feature does to make sure everybody's on the same page. So on channel B, I'm getting my test results at 25 pascals. Sometimes the ducts may fluctuate. Usually they're fairly stable versus the blower door, but here I can actually confirm that my results are 184 CFM at 25 pascals. One of the ones that's not in the code, but this is a interpretation that's been around for quite a while, that if I have more than one air handler and system in the house, that especially if they're on the same floor, which is common for a ranch home, this is common when I lived in Arizona, was that wherever air handler one serves, that's the square footage that I'm going to use for compliance versus whatever air handler two is serving. And they kind of leave that up to the individual for some of the areas on where the return is. A lot of times the foyer, stair areas, all these could be gray areas. So usually, as long as you make a strong, educated guess, most people aren't going to doubt you. And obviously, you can use this to your advantage because we're dealing with square footage per CFM as leakage. So, but in general, you want to make sure that you're not combining the two units as leakage with the area they serve. These are both individual compliance. So one may pass and one may fail based upon how they actually test. So here's an example of a post construction. I'm doing a total leakage test, and I have 100 CFM on my gauge. It's a 2,400 square foot home. So my percentage of duct leak is 107 divided by 2,400, which again is 4.5 or 4.5 CFM per 100 square feet. Just to make sure we're on the same page, this is where we get this number of 107. It actually comes from the gauge on channel B, and we can do the math. It all plays out, and you get a variety of fractions. You know you're doing the math correctly because it looks kind of funky. The big number is going into a small number, and you always get a 0 point something number. When all this gets worked out and we do the 4.4 and it rounds up, that I can actually get this directly from the gauge as I mentioned earlier. So I can actually get this CFM per 100 square feet. So I can now tell if I had to be a 4, technically I'm not passing. If I had to be 3, I'm definitely failing. So these are some of the ways you can confirm as you're testing what I got to do to go make sure I'm getting below 4 CFM or 4%. So I thought I'd just show you some of the options that go along with if I wanted to change and get to the CFM per 100 square feet, that there's also an area that's involved. So if I'm going to use CFM per 100 square feet, I've got to make sure that I change the area that goes along with that. One of the things that people struggle with is they'll tap on channel B and it'll give you these lists, which you can see I have metric, CFM per square foot, liters, metric, CFM per 1,000 and 100, and it'll toggle through each one of those. Whichever one you want to use is the one you'll have that's brightest, and I just hit the home button. But again, if I'm going to do something that's calculating the area for this duct system, I need to know the square footage of the house or the area that it's serving. So the next thing to do is make sure that I'm doing that. So I can either tap on area or tap on settings and make sure I enter that. And you can see that it shows up on the gauge either below here when I'm running a test, or right here if I'm on the home screen. It tells me what's the area that this duct leakage is actually being tested to. All right, I have a series of things that actually show how to do some duct testing. Some of this may be so I'm looking for some feedback here. 4 CFM per 100 square feet. Some people say it's a tough standard to meet. You have lots of neighbors that have been doing this for quite a while that do well with this. And in fact, many folks are getting down to 2 CFM. And if you really want to really reduce this or get it down to something that's a no-brainer, is you bring the ducts into the thermal envelope. Once you've done that, then you may have leakage, but they consider it to be acceptable, unfortunately. So, yeah. Okay.
Yeah, Joe. What was it? January of 2014 that Louisiana passed the code, and they enforced the actual duct testing, correct?
That's
Or was it
correct.
2015?
Uh,
And
yeah, go ahead.
yeah, so at that time, we for Retrotec, Joe and I had created an online training that was acceptable as a certification for duct training. So we used to get a lot of calls from folks, and I remember one day I got a call from a guy in Louisiana, and he was absolutely beside himself because the code inspector that he worked with said that he was not doing the test right because he was at about 1 CFM per 100 square feet. He had installed the work and tested it, and he tried to test again, and I walked him through it, and we looked at everything and came to the conclusion that he just did a great job. And he did such a great job that the code inspector didn't believe him, so he had to actually bring the code inspector out there to test it. But the point is that, yeah, it's definitely achievable, and basically it's all about having a plan, having a methodology or a best practice to do it right, and making sure that your guys know how to do it. Just basically getting that pookie on there, as they say down south. But I thought I'd put that in there, Joe. Back to you.
Yeah, the number one location of leaks that I can tell you that gets missed or forgotten is actually the boot to drywall connection. Most people that are doing this, they're taking their elbows. They usually get all sealed up, brushed on, and then they're actually all installed. Most of the connections are all being done fairly well, but a lot of your leakage can come right where the grill, the register, and the boot all touches the drywall. That's a major area for lower door leakage because it's connected to the attic or crawl space, and also your leakage for your ducts themselves that are actually leaking air right there. So if you're looking for the number one place to go check out stuff, it's that actually section. So I thought I'd show a few things about what we're doing to connect the individual fans to the gauge. And one of the things that the Retrotec system has is there's always two tubes that go to the fan, and that allows you to always turn it around and either pressurize or depressurize. And I'll ask this loaded question: how many folks out there that do duct testing? Um, how many of you are doing any depressurization? Anybody out there says, yes, I depressurize. I do have a depressurization support club that I try to help people with. And I'll explain why depressurizing is a huge resource to finding out that you did the job correctly in terms of testing. So I'll go through that here. So basically, it's a color-coded system that comes with Retrotec. It's not idiot-proof. We keep having more and more better idiots out there. So I refer to as error resistant. The goal is to try and make sure that the dumb things that we all do during the day are not happening. We always are connecting green to green and blue to blue, and life goes on a lot faster. So the rough-in test is part of the code compliant option. So I thought I'd go through a few options for you. There is a battery pack that Retrotec sells. In fact, they don't sell the battery pack, but they sell the cord for the battery pack. And Jay will probably dig up the link and send that to you because that's actually on their website. You need to get this specific battery pack, obviously, and that allows you these options for doing tests where there is no power. The other one I also mentioned in the upper right is that I go and I'll find these foam chunks that you can get from old couches or chairs from Goodwill, and I cut those up for blocks to use for a rough-in test. It goes a lot quicker, a lot easier to use than the sticky tape sometimes. So that's an option for you. In fact, here's what the couch looked like that folded up and got cut into a bunch of blocks that I will use for rough-in tests. And it's a lot easier than removing drywall if you just do a rough-in test. If you have any ducts that are going to be enclosed in the wall, pardon me, or in the floor, you definitely want to make sure you're doing some kind of rough-in test because this could be a disaster later. If you're clearly, if you're in the basement, everything's open, you have access to it. But if you're running ducts up inside the walls or across other floors or other areas, doing a simple rough-in test is always a lot smarter to do than trying to figure out what happened or where's my leaks. The basic post-construction tests we'll go through kind of briefly. Some of this stuff is we all have been living with for a long time. I have to turn off everything else that's actually moving air, any type of exhaust fans. The one thing that is commonly forgotten in that is that you really want to make sure that your ducts and the air handler are always exposed and open to outside, and outside pressure is really what you're after. So if I had a really tight small home, like if I'm doing some of these condos and everything is sealed up so tight now, and I'm doing the duct test and my duct tester is in the middle of the living room, and I'm doing a pressure difference between the ducts and the living room, the common areas, I'm actually going to alter the pressures that are in the area that I'm referring to. So if I'm trying to say that I have a pressure differential from inside the ducts to the living area, and I'm actually altering the pressures in there because there's no way to alleviate the pressures, you're going to actually find that you're going to be kind of chasing the pressure curve there. So I always want to make sure that I have a window that's cracked. It doesn't take a lot to really alleviate the pressures or allow that to happen. The same as if I have ducts that are in a really tight attic or a tight crawl space, that I need to make sure that they have the ability to leak air to some place. So you want to make sure that also including garages. So if you really might have a nice garages or doors are getting really tight now. So if my air handler may be in the garage or ducts are moving through that area, I need to make sure they actually have a pressure relief to expose pressures throughout the system and to the outside. So it's a common thing that people forget, especially as homes are getting tighter, that this can impact your testing methods. The system could seem tighter than what it really is if you don't allow the pressure relief. All right, so it's really common stuff here. We're going to seal all the registers. I'm going to give you some options about what to do. The blue tube or the reference tube will go into the system, the register that's nearest the air handler, and actually that's the input. Sorry, that's the input. The reference is left open. And if you're not familiar with this, Jay will also go through and grab these and send them over to you. Corey Breed has got vent cap systems. If you're doing duct systems and you're tired of all of the tape or duct block on the right side out of California, many people that are in California, they use both of these. These are very valuable. Corey's uses a pole that you can use the pole for each one of your individual covers. The duct block uses a pole for each one of them, and they both have their value in terms of making your production be much more efficient. So we're going to make our connections, do our seals, all basic stuff here. And there is a new clear flange that Retrotec has. And this actually works on Energy Conservatory or Retrotec systems. It'll fit around either one of them. I've checked on both of their flex ducts. But for those of you that have the returns in the ceiling, this is a godsend. Many of you may have already rigged up something that did this, but it's got these push-in clips and it's clear so you can see what you're doing. So you can clip it to the actual grill and it stays in place. You don't have to like try and test as fast as possible before the whole thing comes collapsing down in the hallway. This will keep it in place. You seal it to the rest of the grill like we normally do, and gives you some nice options in terms of being, again, more efficient, much more valuable in terms of your time. So we make our connections. Again, this is the Retrotec system, yellow to yellow, green to green. There's a cord that actually controls the fan itself, and we're up and running. So there is a pressurization versus depressurization. So I did ask if anybody out there was depressurizing. I got a few people. So somebody said pressure only in all caps. So I'll explain to you why I will convince you that you should depressurize. I understand that Energy Conservatory is a little more challenging. There's a flow straightener. It looks like a packing material that you got to put in. You have to add another tubing. But here's one of the things that can happen when you only pressurize and didn't realize you may actually be having an issue if you don't do both. So for Retrotec, I just turn the system around. I hit set 25 and go again. Nothing to change. All the tubing is the same. There's no flow straightener. So it's a real easy way to do that. And especially if I've got a 2-story house, and I may still pass. I may still get by with my 4 CFM, or prior to this, you could actually get away with 12 CFM. So it was easy to be like, we passed, but maybe there was more leakage happening than really what I needed to do. Or you may be struggling to find out, is my device that I'm using to seal all of the registers actually working well. So when you pressurize, little leaks start showing up around the corners, especially if you let it go for a few minutes. Versus depressurization. When I depressurize, all this gets sucked to the drywall, and I get a much smaller, tighter number. We are now struggling with how to get a small number. Depressurizing can help you make sure you're getting the smallest number possible when you actually do your testing. So that's why depressurization can be very beneficial from the difference between 4.5 and 3.9 CFM, because a lot of these little leaks can show up and be challenging. Whether you're using Energy Conservatory or Retrotec, if you are going to depressurize, your rings are going to be inside your flex duct. So you got to keep track of that and make sure they're set up the correct way. I know a lot of folks that do Energy Conservatory, they forget there's an extra tube to be added or the flow straightener. So if you're not doing that, then you're missing the actual correct procedure on how to do that. So if you are depressurizing, your rings or ranges are going to be inside the flex duct. So the first one, which I try to stress to people, I know I have a couple people in California that are on the line with me that we've gone through this. So the first thing you must do, is a common tech support for both manufacturers, is you must reach 25. Okay, I must get to 25 pascals, and after that, then I have if I can't get to 25, I've got to open up the ranges and let more flow go through. So it seems like a lot of people are struggling. Like, oh, do I change this or do I do this? Do I have a different setting? So you want to make sure that your setting always matches the gauge, and I need to let more air flow through in order to allow the pressure inside the duct tester to be able to have enough to get me a reading and get me up to 25 pascals. It's the same as a blower door concept. If I can't reach 50, I got to let more air come through. If I opened up the tester all the way, still can't get to my test pressure, that's when I depend on my add feature, because I need to compare A to B. So somebody else comes back and fixes it and we test again. I need to know that I'm testing always to 25 pascals. So the add feature turned on gives me my results at 25, whether I reach that or not. So the best thing to do is making sure that you're reaching it with the options you have on the fan, and then use the add feature when all else fails. I always turn on the add feature just to make sure I'm always staying stable in that range for that reading. But I don't really want to just depend on the fact that I couldn't get to a test pressure just because I didn't change the range. The other one is some may say low flow, or it'll give me 2 dashes saying I didn't get a reading. That means I don't have enough pressure inside the fan. So I got to get to 25 first, then I got to get my reading, and then I'm able to get my results. So if I can't get a reading, then I got to start making the duct tester smaller. Adding smaller rings is always a great thing. The ratio of leaks to the fan to the system is the same. So I have an open fan, that means I have a lot of leaks, or a leaky house or blower door. So if I have a tighter openings on my fan, that means the house or the ducts are also tighter. I'm going to skip through some of these other slides. So there's some other ones I want to get to before our time gets too challenged. So I'm going to pop out of here and move ahead. So appreciate your patience. Any other questions we want to address real quick, Jay?
There was someone that did point out that that the number, or I think maybe it was a question, but I think she was saying that the number that you use for code compliance is a depressurization number. Is that Sojo, or is
Oh,
that
great. Yeah, thanks. Right. So the code doesn't care what you do. They just say create a pressure differential, which means that you can pressurize or depressurize. Only California and Oregon, I believe, have a requirement for pressurization only. New York follows the ICC as the national standard, and their supplements do not state anything that you must be pressurizing only as part of your test. Same with blower door. You can, if you wanted to, pressurize the house, but we know that we're going to make more a larger number because all of the dampers are going to blow open. So again, depressurizing has your best chance of having the smallest numbers. So great question. So the code doesn't care which way you do, as long as you document. I always document which way I'm testing. Okay, so let's dig into blower doors. This is where things get a little more fun, and our world has changed as we know it. Whether or not your code official will require it, I can't guarantee it, but in general, things have changed a lot. So these are from the amendments, okay? And These are also in the direct code, but they have a few small things that are in the amendment. So I wanted to make sure that we covered exactly what New York has. So your blower door tests need to go down to they cannot exceed 3 air changes per hour at 50 pascals. So that's ACH 50 air changes per hour. And you must now be in coordinates with ASTM E779 or ASTM E1827. And if those sound like foreign languages to you, they are. Because they're not just a single point, set up the blower door, take it to 50, get a number, put everything away. These are multi-point, multifaceted types of tests that do a lot of baselines in the beginning, baselines in the end. They want to know the temperature outside. They want to know the wind. There's a variety of components that have eliminated the ability for somebody to just show up and do a blower door test, right? This is the same for all people that are on the 2015 code. That's a lot of states. So New York, let's see here, Texas, Maryland. I think that part of Illinois may be on that. So there's a variety of folks that are on this code. And I did a webinar that was just on ASTM 779 and 1827, and I got a lot of ran into a bunch of people at our conference, and they're like, Joe, you know that none of the code officials know anything about that. Everybody's still doing the same test. So if you still do a blower door test the same way you've been doing a blower door test, I'm not going to stop you, but I wanted to make sure you felt informed, because we all know that many of our code officials are detailed orientated folks. And once they find out about that, they're going to be like, well, did you follow ASTM 779? And you're going to be like, oh, yeah. And if they have been paying attention or watch these webinars, you're going to get caught. Then you got to go back and do a much more sophisticated test. It takes a little longer, not a lot, but you're going to be using software. That's the bottom line. You now went to a guy in a gauge and a fan, to a guy in a gauge and a fan, and some software. There's a lot of software out that could be used on your phone or a tablet or a PC, but you're now using software to do this type of test. All right, so let's keep moving. And you can do the test anytime. Again, you can pressurize or depressurize. For all practical purposes, we're going to be depressurizing, but ASTM 779 technically wants you to do both. Again, one of those requirements some people may not do, but it's out there. So, but once the home is sealed, especially if you're doing a sealed attic, sealed roof line, I can probably do my test fairly early in the game. In fact, I highly encourage you to do that. If you've got foam insulation in the attic, I got windows in, and even before insulation shows up, if I'm just fiberglassing the walls or cellulose, you can do a test. You can get a snapshot as to how close you are, what's happening with this environment. Even if it's just a single point test, it tells you how well you're doing. And I highly encourage you to do that if you're trying to get down to these new numbers. During the test, it's the same stuff that's been happening for 9 and 2012. But again, we're going to follow the ASTM standards, which have a few more guidelines about temperature and some other stuff, which I have slides on. But in general, it says, close this, but don't seal it. Close that. Leave this open. So there's nothing that you're allowed to do alternatively to adjust the environment that the environment does not have automatically. The number one question is, well, the dryer's not in yet. Can I close the dryer opening? The answer is no, because it has a damper on the other side of that. And although we know that the dryer would help reduce any kind of infiltration through that opening, we're mostly testing the damper. So you're not allowed to artificially cover anything that's not already in place at the time of the test. If there's something that's missing, that's up to you and the code official to determine how to handle this scenario or this situation. But in general, there's nothing that you should be doing to artificially alter the environment just so you can feel as though your number would be more adequate to what it may be once people are actually occupied this house. Dale Sherman points out that for those of us that think that OSB is a air barrier, which I think officially they say it is, but it can be very porous, especially how much has been exposed to the weather. So he wants to remind people to be careful that OSB may bite you if you're using that as one of your primary air barriers. A lot of the stuff we're getting into now has to do with where required by your code official. Testing shall be approved by this third party concept. My opinion is, that's why I make sure we have that. My opinion means a certified individual, whether this person is certified and works for that company or that builder or that HVAC contractor. I personally don't think it's an issue. I think it only has more money if a third person has to come in and do this test, it only adds more time, money, and effort to the actual contractor. So I think if you're not doing a good job, it will show up. More and more people are doing these kind of tests as regular upgrades right after the home is built. So anyway, I think these kind of things haunt you, even if you think you're getting away with something. So yeah.
Yeah, the other thing though, I want to point out too, I talked to builders all over the country about this, and many of them agree that even if you aren't allowed to test your own work, you should have the equipment and the ability to test your own work before that third party person gets there. Because if you're paying $500, $800, whatever, to have your work tested and you fail, then you have to pay for that person to come back out. So again, I think it's a good idea if you're doing any, if you're building, if you're or air sealing or doing installing any equipment that needs to be built to code, you should have the equipment to test it yourself, so that you know for a fact when that person gets out there that it passes. And if that person says it doesn't pass, but you know it does, then you actually have a ground to stand on. So I think it's important for everybody to be able to test their work.
Excellent point, Jay. I'm sure while Jay was explaining that, you could read through that. Again, part of the supplements is you must be providing a report that has these things. I did highlight in blue as we go from here things that I felt were the key things to read. If you're not going to read the whole slide, obviously, read what's in blue. So this is the first time that any code has actually pointed out how to measure the building, and it's an ANSI Z65. There's several different years that go along with any ANSI code, but then they have an exception saying that the ANSI Z65 is something that a lot of appraisers use on how to determine the square footage for a house. And normally anything that's in a room that has a like an A-frame area where it says, oh well, once you get to 5 feet in height, that is no longer considered to be square footage. But this is telling you, we include that as part of the square footage. So you can actually Google ANSI Z65, and you can find free resources for this that's out there, so you don't have to pay for it. So make sure you have the most updated version is the key to that. So next year, probably in January, February, I'll do something that's built specifically on how to measure a building based upon ResNet standards and ANSI Z65. So that's coming to a webinar near you next year. Otherwise, no other questions. We'll move on. These are all pretty basic things. Now we're getting into the more of the, here's where New York has stood out. Many, many years ago, like 2011, Georgia jumped at everybody, even California, and said, hey, we're Georgia. We're going to do blower door and duct testing. They adopted 2009 with some awesome amendments that say, you know what, we're going to step up and show everybody how to do it. And lots of people followed what Georgia was doing, including having this DET verifier or this person who's trained to just be a code tester. And now BPI also has something similar to that. So New York has done the same thing. New York has said it's really a challenge to measure these smaller units, these multifamily condos, and get anywhere near the air changes per hour. That's just almost impossible to do. The home would feel more like a submarine than anything. If you close the doors, your ears would pop. So those are kind of things that were just either impossible to achieve or impossible to live through. So they came up with a much better option, and they actually went with surface area, and as opposed to the volume of the structure itself. So I have a couple slides that also visualize this, but the difference is that we're talking about where 2 or more dwelling units are located within the building thermal envelope. A little gray there, so I don't know if they actually will talk about a duplex that's sharing a wall, the little gray area there. But many of the townhomes may be stacked, or maybe clearly encompassing a thermal envelope that's around the building or in the structures themselves. That's actually a clear definition of what we're talking about here. So we'll go through some examples, but the difference is that this is really what's considered a commercial type of leakage. So commercial buildings are designed about CFM per square foot of enclosure, and the Army Corps is at 0.2. Out west, many folks out there, especially Washington State, they're at 0.4. So we're in the range. We're not actually looking for stuff that's extreme, but this is a lot easier to achieve than trying to do an air changes per hour. So again, conducted in accordance with ASTM E779. I got some slides specifically about that. Once we start dealing with this multiple units inside of a single thermal boundary, they start calling them testing units. All right. And basically what it's saying is that this unit or this testing unit will be defined by the walls in the unit that go to the exterior wall, the walls that abut to adjoining units, or the ceiling and the floor that either go to another unit or go to the ambient airspace outside. So that's kind of defined. Really, whatever you can see and touch inside of the unit, that's your area, that surface area. Can be a little more challenging to maybe add up, a little more math, a little more writing down on a piece of paper some of the surface areas. Sometimes this may come when you get the layout or the design of the unit. But in general, like other stuff, if you can figure out how to measure volume, you'll be able to figure out how to measure surface area. So here's the difference. And we're doing air changes per hour. It's all about volume. More volume you've got, the better you're doing. So that's why bigger houses did much better than these small condos. So if we're doing surface area, we're actually doing all of the walls, the floor, the ceiling, all 6 sides. Even if the unit is on a slab, that surface area is counted. All right. So it's not, you don't count the ceiling, the walls, because I'm on a concrete slab. You're counting all 6 surfaces as the area that you're actually trying to comply with. So there's also, make sure we're clear that this is actually testing all of these units when you get up to 6 occupancies. All right. There's the next slide talks about when I have 7 or more, I have the chance to do sampling. Again, New York has really stepped up their game with all this. So you can go back and test each one of these and do the air changes per hour. You still have that option. This is Plan B option for you to do the CFM per square foot option. All right. So I explained that 2 occupancies, 4, 6. So somewhere between this range here, you can make a decision as to which way you're going to go. Most people are probably going to be doing the square foot option that's there. If you have 2 to 6, you're testing all of the units. All right. 5 units, 4 units, 3, whatever it is, something between 2 and 6, all units are going to be tested. They did realize that, wow, we have a lot of multifamily units that have enormous amount of units inside of them. So let's talk about some options. So this is a building with more than 7 dwelling units. All right. So you do not have to test each one of them, but you have to test each type. All right. So we'll kind of explain what that means. And at the bottom here, it says when approved by the code official. So don't assume that just because your code says it, that your code official knows about it and understands these details. So when you're starting to be doing this as the building's being built, or you know you're going to be the tester or you're the builder, make sure your building official understands this is how you want to test, and make sure they understand what are the different types of dwelling units that you're going to be testing as a sample. All this can be very gray, and you guys are the first out there to figure out how to do this and define that. So you're allowed to group them into sets of not more than 7. 7 is a common number here. So the dwelling must have more than 7 units, number one, and then I can determine what different types of units I've got that can be grouped. And again, not more than 7 different units or common rooms as a sample set. All right. So let's go through what this might look like. So I may have a 1 bedroom that's 800 square feet. I may have a 2 bedroom that's 1,300 square feet, or I may have a 2 bedroom that's 1,100 square feet. So right now, all of these are 3 individual types of units. All right. So let's say I've got, many of these. Let's say I've got 6 of these, 1 bedroom. I can do one of them. We'll talk about what happens if they fail as a concept, but this could be one group. I may have 4 of these that are 2 bedroom at 1,300 square feet. All right. And that can be a group, but I may have some that are considered to be identical, that I may have multiple, again, of these 2 bedrooms, 1,100 square feet, as long as the description was, if you described it on a sales a document, that it's a so many bedroom or so many bedroom and bath, let's say 2 bedroom, 2 bath, 2 bedroom, 3 bath, not the same type of unit. So they may be the same square footage, but your goal is they must be considered to be identical type units. They can be flip flopped, kind of a marriage concept, but you can't say that, oh, well, just because they've got an extra bathroom, it's the same. They technically want these to be identical type units. They didn't seem to care where they sat on the floor or where they sat in the building. They were mostly after, again, are they identical type of units? And again, your building official may have a different concept about how he wants to define that. So you can't have more than 7 of this one kind. I know 7 keeps coming back. So if I have 8 of this 2-bedroom, 1,100 square foot, then I would actually have 2 groups at that point. So there's many nuances. And if I have confused you, then welcome to the club, because this was a challenging amendment that they added. And there'll be some more clarification as this all gets kicked into gear. So hopefully I'm providing some clarification or some better questions to make sure we're all on the same page. Anything on there, Jay, that I need to make note about?
No, just got a note though from Daniel that said that they usually do sample sets based on 1 bedroom, 2 bedroom, 3 bedroom, etc.
That's right. And to confirm with Daniel, does that include a bathroom? So if I could add 2-bedroom, 2 bath, and 2-bedroom, 1 bath, that would be the same? Or how do you guys define that, Daniel? You can let us know in the background. Thanks. Okay, so here's how it breaks down. Again, all this is in the document that we allow you to download and gave you the links to. That if you're doing it and you do verified of that my sample set is working, then the remaining sets don't need to be tested. If I do it in part 3, is if what if I do one and it's not verified, the one fails, then it says at the bottom, 2 additional tests of the units need to be tested. All right. So we can keep going with, well, what if? So if any of the tests in accordance with paragraph 3, let's say one of these other 2 fails, then I'm testing all the units, all 7 in that sample. So what it doesn't say here, to make sure everybody's on the same page, it doesn't say I need to go fix those other houses, those other units. That's been a challenge with any code that deals with this. Georgia has the same kind of concepts. It says, well, you can do some sample, and if that fails, then just sample more. And then eventually test all of them. But my assumption is you'd have to fix these units to make them compliant. You're just trying to give a ballpark as to that, oh, this one didn't fail, but the other ones did. That's okay. Let's fix the one that failed. But it didn't actually state that. So I would make sure that you understand that just because you fail doesn't mean you get to leave that unit alone. All right, so this is a home slide that I like to use. We take these average homes, we cut them up, we make Swiss cheese out of them. This is why we're doing blower door tests. This is exactly why we need to be doing blower door tests on more multifamily units that have been put aside or left aside. Is that there's an enormous amount of leakage that's between units and between floors. Just to make sure we're all on the same page, is that you according to my sources, you cannot do a neutral pressure boundary or guarded test around these units. Let's see, I got a middle unit on the 2nd floor. I test that unit by itself, but I could not add a blower door to the left or to the right or above or below and find out that, well, the leakage outside is one number, but leakage to the adjoining units is something different. This is total leakage. This is wherever the unit leaks is considered leakage, and that's part of how your blower door test is done. So you cannot neutralize or eliminate adjoining unit leakage. So it's all anything that leaks out of this unit is considered leakage to the outside. So I want to make sure we're all clear there that you cannot. This is a single compartmentalization test, not something that I can actually neutralize with the units next to me. So based upon that and these kind of illustrations of the kind of leakage that we're going to have, is that we're going to do a much better job of sealing the units that are adjoining next door and above and below. I did several tests out in New York with some of the folks out there, and the leakage from side to side wasn't that bad. It's the chases that are put into these units are just a massive air leakage source that you can actually feel the amount of wind that just flows through the entire structure because these chases are open to every single floor. That's how they're running the bathroom. That's how they're running the conduits and the electric and low voltage wiring all the way to the roof. Those are the major killers that I can predict you're going to see. Is how do I compartmentalize, separate this unit from all of the chases that are happening between each individual floors, so that we can eliminate the Swiss cheese effect that we have in all of our units. This is one of the ones. I'm sorry, I'm probably going to go over a little longer. Your topic was a pretty heavy duty one, so I did try and get rid of most of the extraneous stuff, but I do have several things that I think are very beneficial and help your business model in general. This is the actual 2015 air barrier insulation inspection guideline, and this is one of the things that it technically has to be done. This checklist must be accounted for, or at least say that it was done in conjunction with your blower door test. It actually says this thing must be done. And I can tell you that if this is done and done correctly, then you have a high chance of passing your blower door test. It's when people ignore the visual concepts that they think that, yeah, it's good enough, it's fine, just because I'm not caulking around my base tracks between units, it'll be fine. The drywall goes down, I got trim. None of that stuff is considered to be air impermeable, or is it an air sealing product. So um, this checklist will make sure that you're incredibly successful, and it is actually a requirement. Even though it's not something that people ask for, you are required to actually evaluate these areas. The one on the right is from 2009. And South Face has these awesome images, and Jay doesn't have them. I have them ready to go. That I can actually give you some of the links to these. So
Joe, I actually got them in there.
Oh, you did? Okay, right.
Yeah.
Well, you get 2 copies now. You have 2 copies in there. Jay, you're too fast, buddy. So these are your air sealing details that kind of go along with the checklist. The checklist is changed from year to year. But if you want to give this to a builder, or if you want to use this as your own concept of a checklist, it is a great resource. People that follow this checklist with itemized numbers have a high success rate of passing, especially if they're not used to doing blower door tests or making sure all of these things go through. And again, it's just a nice job of actually showing different things between knee walls, what's changed in terms of the insulation has to be on touching all 6 sides. That becomes an air barrier. All these things become a much more efficient, much more comfortable home when they actually are able to visualize. One of the things that I've always was frustrated by is not being able to visualize what the contractors need to do. So they also have a field guide that goes along with this. To make sure that these are made by Southface, but they were under a federal grant, which means you're allowed to use them. It's okay for you to hand out these pictures or use them in your marketing, use them in whatever way you want. That's one of the things why Southface made them, is so that more and more people would be building better buildings to be more successful. So do not hesitate to use them. I try and give them credit whenever I can, but in general, the field guide and these illustrations are an awesome resource for everybody to use as needed. I'm going to skip through some of these kind of quick. This kind of just shows why our air barrier isn't just the drywall or the OSB or other, hard surface products. That our air barrier becomes anything that penetrates the air barrier. Drywall is the most common air barrier we may have, and as soon as your air handler penetrates it or the can lights it, that actually becomes the air barrier. And that's why it's really crucial to make sure your duct system is sealed or brought into the thermal envelope. And the best way to have a tight structure that's well ventilated is to make sure that I'm reducing the amount of penetrations that happen in my air barrier itself. This is a great slide. Many of you have seen this, but if not, it just really hammers home. This is actually a southern climate, but it really shows why it's so valuable. These are both 2 pieces of drywall, standard drywall, and on the left we have vapor diffusion, which means this is the amount of moisture that moves through the actual drywall. And on the right, we have the same concept. These are really great conditions, 75 degrees, 50% relative humidity. But on the right, they cut a 1-inch hole to find out how much more moisture would move through the air leakage that we have. And in 1 week in a southern climate, I've got 1.5 pints of water, which is a fair amount. A 1-inch hole goes to 14 pints of water. And if you're dealing with durability issues, you're dealing with comfort issues. If you extrapolate this to northern climates, that may be more like 30 pints over a winter season or a summer season. But that's still an enormous amount of moisture issues that happen just from a small amount of air leakage. Most of the homes you're going to be building or being code compliant still have a 1.5 to 2 foot opening. If you added up all the leaks and gaps and cracks all around the house, you still deal with a huge opening that may feel as though this house is really tight. Passive houses have more like a softball size or a hardball, or much smaller. Maybe you can get down to 2 square inches, but you have an enormous amount of effort to get to those kinds of real tight homes. So in general, a code compliant house can still easily have a 1 foot by 1 foot type opening.
Speaking of openings, we have a question. I don't know if you pointed this out yet, Joe, but what is the max ACH 50 number, or the allowable amount of air changes per hour at 50 pascals in the New York code?
3 air changes per hour.
Thank you. Yeah, 3. Thanks, Stephen and Dale. Thank you.
Yeah, thanks. too many numbers in one webinar today. So again, doing the air changes per hour, which again is for the single structure, single family type home. These same calculations can be done in the gauge. This is why I got attracted to Retrotec, is because I could do a ballpark in my duct leakage, but I could struggle to figure out what was my air changes per hour in my head. You get a feel for it after a while, but in general, I can actually be running a blower door and say, oh, we passed. Oh, no, we didn't pass. So again, right here, I am struggling to pass. I do have a opinion about 3 versus 3.45, not to exceed 3. I don't know if 3.45 technically exceeded 3 because I'm not at 4 yet. These are all things that are very vague and still have yet been resolved. You may say, well, I'm above 3, and that's okay by me. Yeah, and it's easy to get those in the gauge. I'll kind of flip through some of this. I have some things about the ASTM test that I want to get through. And you can do what's your estimated leakage surface area in square foot or square inches in the gauge also. So these are all great things that many people wonder, well, how big is the hole? How much leakage do I have? Again, the gauge can actually do all that stuff in it live while you're doing your test. I'm going to skip through the baseline stuff. A lot of this stuff is done, stuff we've been familiar with. I felt that there were so many people that were familiar with what kind of testing they were doing or how some of this stuff gets prepared. The one thing I will tell you is even on a new home, I still want to encourage people to go to the attic, go check out the duct system, or at least the garage and the crawl space, because you never know what's behind those areas that you were not aware of. Okay, so you are now also in the age of mechanical ventilation. No matter what you do, you require mechanical ventilation because you are anything less than 5 air changes per hour requires mechanical ventilation. Does the code say you have to have mechanical ventilation? No, unless you're below 5, and you have to be 3 to pass. So in theory, you always have to have mechanical ventilation. And this is not just in the mostly is in the IRC and the mechanical code where it's stating that. So once you're here, you now have mechanical ventilation. There's a whole nother webinar series that's just on mechanical ventilation, but in general, that's out there. You also should be requiring to do manual J. How many folks out there are doing manual J? I know it's a thing that some people do. Some people live by it. A manual J can be done now online with a Google search in terms of it'll actually look at your house, determine your square footage, and can actually do one online and give you your manual J calculations. It's pretty amazing how far we've come. So I thought I would give people the idea that I'm going to do my manual J before the house is built or while it's being built. But you should really be using real blower door numbers. So I did a reverse calculation to let people know that in general, these are the kind of numbers that you would get if you use just these presets. If I use tight, semi-tight, average, those are the kind of numbers that would be calculated on around a 2,000 square foot home. I did do a larger home, smaller home. I took the home and moved it around the country. So in general, these are the kind of numbers you get, and they come into these kind of numbers. So for you, if you're going to do a manual J, you should be assuming that your home is going to be semi-tight. So some people just go, well, I always use loose just because it's a safe thing to use. You're actually going to be overestimating your infiltration and causing a much larger, probably at least one size, if not two, of the potential size of furnace that you might be looking for. You may be upgrading significantly. So if you're doing manual J, in general, you should be using the semi-tight as a ballpark function because you don't know what your blower door numbers are yet. Okay, let's dig into the 779-1827 conundrum here. If you're going to go Google ASTM E779, you would find lots of older versions that are incredibly different. They are not minor changes. So 1999 is one you can find a lot of, as well as 03, and they have very significant different requirements. So if you're going to do this, make sure you're working on E779 2010. Otherwise, again, you'll be doing stuff that you never needed to do. So again, this is your now new world of how you do blower door testing. There's a variety of recommendations they actually have in the 779 about where you can and where you should not be placing your reference tube. Again, this is for the blower door. My red square is the blower door. They really don't want you to put it in places where we're kind of aware of. Don't put it into a corner where the wind could be increased on your for your baseline measurements. A single point, which is what many of us are used to using. These are what you have to do. And for the multi-point, has a whole different concept in terms of what we have to do. We still do these, right? Because they want to make sure that ASTM didn't spell this out, that you should be doing these things that are part of all their tests. But we need to have elevation. You need to know what your sea level is. You need to measure your indoor and outdoor pressures. On the windward side, there's a pre and post baseline. They get averaged at the end. It's not something you keep the baseline in the gauge itself. Your induced pressures go between 10 and 60 pascals, so it's a multi-point test. Most software goes between 10 or 12 points in terms of its reading. So you have to have at least 6, I believe, a minimum of 5. You have to have 5 readings. Most of the software by Energy Conservatory or Retrotec does many more readings because you get a much better result when you have more numbers to average. So here's an example of some of the things that are a challenge. And I called, even if you're going to do a single unit on, let's say, the 12th floor of part of your sampling technique that goes along with just your do my several a unit that has more than 7, that this still comes to be part of that. You must still follow the 779, and it says that your temperature difference from inside to out times your building height in feet cannot exceed 1180. That's just the number. So if I have a 25-degree temperature and I've got a 40-foot building, I'm already at 1,000 foot degree temperature. So for those of you that are dealing with larger, taller structures, and you may be doing this in colder weather, then you need to be selective as to whether or not you get an override by the building official as to whether you can do this, or you're going to have to work on come back another day because it's too cold outside. So these are some of the challenges. I have the feeling that these things will get kind of revamped or rewritten or worked out of in terms of the requirement. I don't think everybody knew the nuances of 779. And the reason that I say that is because this is software. Your software says, hey, what's the temperature outside? What's the temperature inside? How tall is your building? Guess what? You can't do your test today. You can still do it with the software, but it's saying that you didn't comply with one of the features that this ASTM requirement had. So at the bottom, it could say you failed or you passed everything except the temperature and height requirement. So we no longer have the option to just ignore things because the software is trying to make sure it encompasses all of these types of requirements. It also says that you must depressurize and pressurize. It's actually in the code itself for 779. Again, not something that a lot of people will be doing, but again, it's the nuances that you should be aware of and make sure that you understand what is required versus what is acceptable by your building official. Why do we deal with multi-points? So what's the point? A single point is really just a quick snapshot. The different of repeated single points or multi-point tests is that I'm getting more data I get, the more chance I have of being accurate. So ResNet has a multi-point test. There's several ASTM, U.S. Army Corps, NEB, and ABBA all have different versions that are all of E779. 779 has some issues. Everybody else said, oh, let's make it better. NEB and ABBA both adopted that. One more that's not on here is the ASTM ResNet ANSI standard that's called 380. I think that'll be incorporated into everybody's testing standards fairly soon because they did one more job of saying, well, let's get rid of these frustration things that 779 has, but we like their math. So a lot of these things are being resolved and being brought up to date. So here's some of their comparisons between 1827 or 779. And the reality is there's a bunch of calculations that have to go into this. Air density and dynamic viscosities and just a bunch of stuff that, for most of us that have a gauge and a fan and can find leakage and fix it, this stuff is for an engineer. And here's the math. If this is the kind of math you love doing, then clearly this is the kind of stuff you can figure out how to do with your spreadsheet or Excel. But in general, the software does it for you. One of the software packages that's out there is Retrotec has a thing called rCloud. It works on Windows. It also works on Android devices. We're working on Apple. I know many people have Apple. We're hoping for early next year to do beta. If you have an Apple device and want to do beta testing, send us a reach out there and let us know that you'd like to do that. You can download this app right now for Android. It's still kind of in a beta testing version, kind of with Windows, but in general, you're able to run an ASTM test on your phone or your tablet and get all the results you're looking for. We feel this is going to be a change in how people do code compliant testing. Whether you actually have internet or not, it still will always work because you're always connected to your gauge with Wi-Fi. But if you have these other features, it will do a great job of updating and sharing your information, or just recording it and letting you update it later. If you have LTE, you always have geolocation property, so it can always tell you where you did your test and who did it and where. So these are the kind of things that we think the industry is looking for and will make a great supplement. So even if I don't have any LTE, I'm in the middle of nowhere, New York, I still have a GPS signal on my phone or my LTE tablet, and I can always determine by latitude and longitude where I did the test. There's a couple other software components that are out there. You can also go to Retrotec and look at some of their other software options. Fantastic is one that's out there that allows you to do your automated testing by merely saying find my gauge, similar to the R Cloud, but it will, and it does all the nuances. This was designed for more of a large building or multiple fan concept. This is out there, and you can use this as a concept, and it has a free version for 30 days, or you can upgrade and use this. I do think R Cloud will be something that kind of replaces this, as maybe more of a large building type of a procedure or option, but want to make sure you knew what your options were that are out there. Tech Tight and Tech Log do things that are very similar to this, and they are free. I found it a little cumbersome to use that software in general, but there are options on both manufacturers that do this. And there's a variety of stuff that actually control your blower door or duct tester remotely, so you don't have to be exactly where you're testing. So I can actually be doing my CAS test as an example. I can be upstairs and have my gauge downstairs and actually go around and run my CAS test. So these are things you can also use for Apple directly right now, or Android version. This does not work on a PC. This is more of a tablet type of a phone software.
All right, Justin, whenever you get caught up, let me know. I've got a few important questions for you.
Okay.
And yeah, let me know when you're ready.
So many of the stuff that I kind of skipped over, we've done in many other webinars, probably within the last few months. If you're looking for more detailed information about any of that, the software, the details about how to do blower door, duct tests, or any of those things, including the 779 tests, you can find those on youtube.com. Retrotec Energy is the username, and or you can go to Retrotec site and actually find many of that stuff on the exact same videos. But I really appreciate everybody's time. I try to do it in an hour. This was a heavy duty topic, and I only was focused on some of the things that were specific for New York. So hopefully we enlightened what it is you guys are doing for the rest of us. So let's handle some of your questions, Jay.
All right, so Gordon wants to know, are blower doors mandatory, or is the prescriptive path still possible?
Prescriptive path is possible, but blower door is mandatory even in the prescriptive path. So just make sure we're clear. Some of the stuff that I thought I had, intermixed here was may not have been clear. So you are required to do a duct test, although you do not have to have a certain number to potentially pass unless you're prescriptive. Blower door test, you must do a blower door test, and if it's a single residence, you must be at 3 air changes or less. If you have the option of having multiple units under one thermal boundary, then you have the other option of actually doing 0.3 CFM per 100 per surface area. So no matter what, you're going to do a blower door test. It depends on the type of unit that you may be testing. Depends on what your options are and how you may test it.
Okay, thanks. And Dale Sherman from Niswata and wants to know, Energy Right as well, wants to know points out that New York State is considering ANSI 380 blower door testing for weatherization programs. Will this be an acceptable procedure for testing the code?
So many of those hotlines, those numbers that we gave you, I have an intimate relationship with some of those people because I've been calling them over the last 2 weeks saying, hey, what about this? You guys think about that? What's the answer to this? Especially with some of these nuances with the multifamily, more than 2 structures, more than 7. And I gave them, reminded them about some of the challenges with the 779 and told them that there is a standard that is the ANSI approved, ICC approved 380 standard. And right now 380 is going through just went through another set of edits, and it's out at ResNet for discussion. So if you want to read it and get your input, you can go on the ResNet site and go through that. If you can't, then shoot me an email at joe@energycode. I'll send you the link. so you can see what are the next alterations that are happening to that code. I do think that New York will make an adoption, but it's always hard for a state to do that, or a city when they just already adopted a new code. But that doesn't mean that your local municipality may not say, "Oh, we also accept that." The 380 is basically just a very clear, defined testing standard for a variety of stuff, from everything from testing exhaust fans to duct testing to how to do a blower door test. It's all in there and spelled out pretty clearly on how to do that.
All right, so I'm answering some questions in the back. And oh, here's the good one. When does one follow E779 versus E1827?
So the reality is that uh, to make it simple, if you're going to use the software, it depends on if the software will do E779 or 1827. Again, these are things you just can't do with a pad of paper or even an Excel spreadsheet. They're very kind of complicated setups to do. So that's why the software just says, don't beat the system, join it. Retrotec right now only uses E779 because it's the most common standard out there for anybody that does large building testing. I only know one person that actually uses 1827. So does that not mean there'll be some things that'll be modified on how to do 779? I predict that will happen fairly soon. But so if you want to do 1827, you can actually modify the fantastic software to do that. It's a little cumbersome, but in general, if you just followed 779 and hit go, it will do everything and tell you to turn your fan around and do it again, and it's all automatic. It is Retrotec's goal to add 1827. That'll be sometime in 2017. It'll probably be late in 2017, but they're probably going to add that to their fantastic software, and we'll try to probably add it to our cloud. But right now, our goal is just to get things out and get them stable, and then move on.
Can we get an email when this is up on YouTube to watch again? He was talking quite fast, and I'd like to review. Yes, Joe talks fast. Joe, when people from New York are mentioning that you talk fast, you know you're talking pretty fast. You
Okay,
should
so
imagine how he feels in Atlanta.
yeah, right. So okay, so what kind of accent do you guys think I've got? So that's my question in the background, though. So let's see. If I know I talk fast, but do I have an accent? So that's really my question. And yes, we can send a group link out there when this actually goes up. So Kirsten, who's actually a New Yorker, will make note of that, and we'll send that out saying, "Hey, here's the blast." So, any other questions? Anything else people want to like throw out at the last minute here? I appreciate for those of you that stayed out much longer, held your dinner. Hopefully, it's not cold. And usually we do these at 2 o'clock, so we did one later in the day to hopefully benefit your time. So if this is a great time in general, let us know that because we can try to alter that for next year.
Well, this has been an excellent group. There has been some fantastic questions. There's been some incredible insights. I've tried to share them as much as possible in the background. I have been, my fingers are burning up with fire because there's been so much going on. I want to definitely point out that Daniel, if I can use your name, Tempanaro, he just wanted to say thank you because you didn't rush through everything and you got deep into the meat of when other people don't, and really got a lot of good input from David Minch, who is an architect who had a blower door in 1985. So and I jokingly said in the background that not only is not only was he the only architect in 1985 to the only one to have a blower door, he might still be the only architect that has a blower door. But he's got a question, and I think it's a pretty heady one. So I'm gonna throw this one to you, Joe. His question was, does a test for single-family residential using ACH 50 at zero point 0.3 CFM per square foot meet code?
It's not. No, I say no because it's actually your code amendments do not allow that. It was only for a structure with 2 occupancies or more. Are you allowed to use that? And it was really designed for smaller structures than it was actually for a normal single family house. So a way to say that's nice and slow, Jay, very good. But unless your building official sees otherwise, that's not a compliant path. If you have a single family structure, you're following the regular 3 air changes per hour. There was another question here about is this just new construction? And this is primary new construction. It does apply for remodels or additions, and every state gets a little gray with this. So for the blower door, it's usually only if you're altering a room that gets completely opened up to the interior to the point where I now need to test the entire interior. Sometimes you're just converting a garage or something. They don't consider that to be an enormous amount of changing the envelope enough to do a test. Or if I add an office to the back, many times they don't require that to be tested. It wasn't clear here, to my knowledge, and maybe I had to dig deeper. Now, the duct system is a completely different animal that's not always clear until your jurisdiction decides that if I change out an air handler, I keep the duct system. Whether or not it needs to get tested is never really defined for changeouts. And I would ask what their policy is on that. Anything else?
I think that's about it, Joe. And I can hear, I can see the people dropping off right now, and I can almost hear the dinner bells calling them. So I'd like to say thanks. I thought this was a great one, Joe.
Yeah, a lot of great folks in the background helping us out there. A couple Kevins, some Gregs, Dale Sherman. Always good to see you on our webinars. You're doing awesome work wherever you're at. So many of the rest of you, I see you at shows. I see you on these webinars. We've got folks from California here today. So again, it means a lot that we get a good turnout and we get great responses. When we have people chatting in the background, it's always a great webinar. So is there anything else you felt we were missing, what we should be focused on next year? Throw that out. I can tell you that I will do this webinar again, probably in early February, because to me it's already now in a box shell. I'll go back and revamp it, clean it up a little bit, and I'll do it again sometime in the first of the year when a lot of people are wondering what am I going to do for the homes we just built. So look for your emails. Go back to the Retrotec site, and you can always log on. Make sure you're part of the newsletter, because the newsletter always outlines what we're doing and what's coming up this month. And we'll see you definitely next year.
Yeah, Joe, and one more thing. We did get a couple of people that inquired about doing this similar webinar for other areas, and I just want to let everybody know that Conrad, Joe, and Conrad from the BPCA, they got together and decided that that this was something that that you folks would like, and so Joe went to Retrotec and did that. So if you're from Connecticut or Minneapolis, Florida, any of these other areas where you think in California, where you think that you'd like to have something sort of a specialized offering for your group or from your area, get a hold of Joe and let him know. And I think that we can definitely work that out. And that's easy to get a hold of Joe. It's Joe at retrotec.com, or Joe, and it's Joe at energycode.com.
.net.
.net, energycode.net.
Anything you send to Retrotec would find its way to me. So just anything you got, it'll get there. This is our last webinar for the year. So I bring up the Retrotec website and show, oh, here's what we're doing next. But we're not. And our massive amount of webinars that we normally do is going to be kind of on scaled back, so we can kind of do better webinars and do a little less of them. So we'll be doing at least one, maybe two a month, and we're going to be focused on some real serious focused training on how to do individual items. We're definitely going to be focused on the 380 next year. That's a testing standard that will be used by many of folks. A variety of stuff on ventilation, and our goal is to try and make sure we're focused on your skills and how to improve them. So I want to say thanks for all of you that have been there. Jay in the background, he has been just huge for helping me out, as well as all the other folks from Retrotec, Kirsten and Jack and those folks. So thanks to everybody. We will see you next year. Have an awesome Merry Christmas, Kwanzaa, whatever it is you believe in. Stick to it, and have a great New Year. Jay, you want to say something else?
Bye-bye, everybody.
Take care, everybody.